in the chat to let us know that we're talking to humans. Okay, hello. I am Megan Sullivan. I am a senior software engineer here at Gatsby. I work mainly on the documentation. And this is Ward Peeters. Do you want to introduce yourself, Ward?
Yes, I am Ward Peeters. I'm from Belgium. I also work at Gatsby as a tech lead, mostly focusing on the open source side of things. And I know a lot about performance, so that's what we're going to talk about.
Hooray. I'm really excited. I don't know very much about performance, so I'm hoping to learn a lot of cool tidbits.
I hope so
if
too.
you're with us, yeah, you're going to be great. If you're paying attention in the chat, we're going to have a swag giveaway. We'll drop the link to that later, so keep an eye out. All right, Ward, I'm going to pass it over to you now. Do you want to share?
I'll share my screen.
All right.
And then we go to, do you see it?
All right. Yeah, I think you're good. Go for it.
Okay. The name of the talk is like, why can I get 100 on Lighthouse? Like there's many, like we get many requests and people are always shouting about, like I get a 70 or a 60 or an 80 or a 90, but why can't I get 100? And does it even matter to get 100? Because now with the whole SEO rollout that Google is going to do in June, like it was first May, but they postponed it to June. They're going to do like a small rollout, like a gradual rollout where they're going to measure page performance as part of the metric. Like no one really knows what they're measuring, but they say this the core web vitals piece, which basically comes to my next part of the question, like where do we start? Like what does fast mean? Because we always talk about performance, but what does it mean? Like what are we measuring? What is fast to us? And it is kind of tricky because there is no one solution fits all, especially when you have multiple frameworks, like you have React, Angular, Svelte, or maybe vanilla jQuery. They all have their pros and cons when it comes to performance. And then with Gatsby, we try to optimize a lot that React does, so that at least the user doesn't need to care about. But we've seen that there is so much going on in a web application that the user needs to care, like we can only do so much. So we're going to talk about how can we move the needle. And basically what Google says is we have 3 metrics that we're going to look at, like largest contentful paint, LCP, which basically loads or measures the loading experience of a user. So like how fast can someone see the page being ready? And mostly, or what LCP kind of measures is what's the biggest piece of your in viewport page, like what's the biggest piece of it and when does it get loaded? And mostly it's like your hero text, like your big text, which we'll view in like in a few minutes on our own gatsby.com, what that means. But it could also be images and all of those things. So that's basically where the user feels like, oh, the page has been loaded. I can start reading or interacting, or at least thinks it can interact with it. Then there is first input delay, FID, which basically measures interactivity, and it measures how fast do I get a response when I click on a button, or when maybe you do a swipe or scroll. So that's basically what it means. And then CLS is how stable is my my web page, and mostly this is to measure how disruptive like pop-ups are or ad pieces. Like on a lot of publisher websites, you'll see your page and then it shuffles in like an ad at the top, maybe in your article, and your web page starts to jump. And it's just an indication on like, is it good enough or not? And it doesn't have to be perfect, like as we can see on the scores here, and I'll go deeper into them. Like good is if it's faster than 2.5 seconds for LCP, for FID if it's faster than 100 milliseconds, and then for CLS if it's smaller than 0.1. I don't really know what the values here mean actually. But it's like you can have a small layout shift as long as it's not too disruptive, it's fine. But then when we look at Lighthouse reports, you mostly see like FID is not part of it. It basically gets replaced by total blocking time. And this is a piece of the puzzle that is tricky with React, where React's hydration step could be really expensive. And I know I'm doing a lot of theory right now, but we'll soon jump into the real world and check out what those metrics actually mean and how we can improve them. But the reason why FID cannot be measured by tools like Lighthouse or Webpagetest is that it needs user interactivity, and you can only measure it well enough when there's a real user, because what robots can do, like Lighthouse, they can start hitting a button and click on it and measure how fast it is. But there is nuance here. Like, let's say you have an article page. I'm going back to a publisher because, or a blog post can be there as well. Like when you're reading or when the content is there, you might not hit a button. So what if the robot was clicking a button at the top? Like how good is interactivity? It might not make any difference for the user experience because they might not even care about the button. So that's why they removed it from the lab data, like from Lighthouse, Webpagetest, and all of those. And they're basically looking at total blocking time. And total blocking time is when you have a long task, which 50 milliseconds is a long task. And I'll jump to the explanation of those. They're all on web.dev and then /tbt. Like, it's probably hard to read. But it has really great graphics on what does it actually mean. And it's also helpful to, like, okay, if you understand what the metric means, it's easier to fix them. And Megan, if I ramble too much, feel free to interrupt me, or if questions come up, just jump in and pause me.
Yeah, you're doing great.
So basically when you have JavaScript and you call a function and it takes like 100 milliseconds or 300 milliseconds, you can think of like looping through a million items. Like, because you're doing a for each, you don't give the browser any room to breathe. And then you basically take up like maybe 250 milliseconds or 90 milliseconds. And everything that's longer than 50 milliseconds gets measured as total blocking time or like blocking time, and then they get all added up, and then you get your measure. And this is basically the number you will see in Lighthouse. The same for first contentful paint. Again, like web.dev has great information here, where it shows you what FCP means for this one. So basically what this metric shows is like which is the biggest piece of it. And for this page, it seems to be then the top bar. And now we'll go to like our own website to see what it actually means. So if we go to gatsbyjs.com, like, okay, this is not the live website. Like, this is my local one, but let's just go for gatsbyjs.com. So I can run it locally. So it depends, like, let's say mobile, I'm pretty, like, we can already see what LCP will be. It will be like this piece of text because it's the biggest thing on the page. Like, we have a banner here, but if you compare the height and width, it doesn't come near the headline. So let's say if I would do a quick Lighthouse test, I would see that LCP is the text. And maybe it's, I don't know if it's already shipped in. Okay, so here I get the div. And then in like PageSpeed Insights, you'll see the image as well, but that's for another, like in a few minutes. So you can see that the highlight of this one is, this is LCP. So we have to make sure that this one loads as fast as we can. And like I said before, like images and fonts or text are the biggest contributor to this metric. So you kind of want to get this as fast as you can. So for images, you want to preload them, which Gatsby plugin image does all the magic for you. So if you have images, use our Gatsby plugin image. It will make that your images load as fast as they can. And then for text, the thing we see a lot is when you have web fonts, they change your text, because if you have a fallback font, like it could mean, so this one has Futura, so let's say we do not load Futura but the default font. This will be the default one, and then when the web font kicks in, it will change. I don't know if it changed, probably if I refresh. And this is like a minor change, so it wouldn't change the metric, like LCP would just be the same. But if you have, sometimes what happens is when your fallback font is not similar to your web font, you'll see maybe jump it from 3 lines to 4 lines or from 5 to 3. And that's where LCP matters then. So you kind of want to optimize your font loading here. And that's what we've done, but that's for like later in this session. And then other metrics that like we only shown these 3 ones, but there are way more metrics that you should care about. So let's say if we go back to our Lighthouse test, it shows more metrics, like it shows largest contentful paint, first contentful paint, speed index. And I think I made a mistake. Like first contentful paint is the first image or first biggest piece of your metric that happens, and then largest contentful paint is what's actually the largest piece on your website. So first contentful paint could be is probably like the first paint you get, and we'll see that at Webpagetest, where you have a better image tracing than here. Like this is basically how you see Lighthouse loading your web page. And then first contentful paint would be this, and then largest contentful paint could be the same. But like when you look at this one, it's not the same. So it's 600 milliseconds later. So we can dive into that later.
Hey, Ward, can you make your font size a little bit bigger in your browser?
I can. This is better, I guess.
Yeah, you can probably even do a couple more.
Okay.
Perfect. Thanks.
So you can see that these numbers are 600 milliseconds apart, and technically you want them to be the same. But I don't like the Lighthouse DevTools here. I think Webpagetest does a better job here. But that's like a so when we look at like time to interactive is a metric here, but it's not, at least what I know, it's not part of Google SEO measuring. So, but it's still like you always have to find balance between like I want to optimize SEO, but I also want to optimize for my user. So I could improve first contentful paint. I could improve first input delay, and I could improve CLS, but that might only satisfy Google search. But like Google search is only a small part, because Google search doesn't give you any money when you have like an e-commerce business. So you should also focus on your users, and that's basically looking at all these metrics. So let's go back to this presentation. So talk to about total blocking time, and then what's the best way to measure. So we have to, like I said, with TBT, total blocking time, and first input delay, you have to split the way you measure or you talk about measurements. Like you have in the field, which is like real user monitoring, basically having real users go to your website. So and why do you want to do it? Because when we look at those metrics, like the 2 seconds, 2.5 seconds for LCP and all of those things, when you run like a Lighthouse test or maybe something else. They will run it on like a emulated Moto 4G, like a really old device, and a fast 3G connection. But let's say all your users are on Wi-Fi for some kind of reason, or they are on 4G. You maybe don't need to spend all the time on the Lighthouse scores to get it to 100. So maybe if you just make it right for your users, and that's where like real user monitoring can help. And you don't really have to implement it yourself. Like there is Crux, which is Chrome's way of measuring data. So it basically anonymously fetches data while you use a browser and you opt it in. So it just collects all these numbers when you search or visit websites. And it's available in Search Console. I'll show it how it looks for Gatsby in a second. And then you can also implement your custom events in Google Analytics, which will be adding a feature to our Gatsby plugin, Google Analytics plugin, fairly soon, where you can just enable the option measure core web titles, where we just measure those numbers, and then you'll have that data too. Because Crux, I don't believe it's running on every website. It's only on like a small subset, but the small subset is, I guess, 100 million sites or something. I don't recall the number. Maybe it's even bigger, like 1 billion. And then third parties, you have like tools like Calibre. No, Calibre is also in the lab. So you have SpeedCurve. You have, I think, Boomerang from Akamai. Like you have many third party that can track it for you. And then in the lab are the tools that you mostly use during development, like Webpagetest, PageSpeed Insights or Lighthouse, or just your Chrome DevTools. And it's great to have it on every pull request or do it occasionally, just to make sure that if you have the data on every PR or every commit, it's easier to like measure like which change made it worse or bad. Like you wouldn't get the same results as your real user monitoring, but that doesn't really matter for in the lab data, because the longer you measure on the the thing you have to be very careful about, it has to be the same condition. So if you test during Webpagetest or whatever, you have to make sure that the device you test on and the URL you're testing on or the server is reliable, always doing the same, like showing the same content, showing the same like performance and everything, and that your device doesn't change that you're testing on, because then you can only be sure that your metrics are reliable, because you don't want to be fixing scores because your testing isn't set up right, because maybe you have a PR but your server went down, so your numbers, or your server went slow, your numbers went from 2 seconds to 4 seconds, and you're looking into your PR and nothing makes sense for that change. You don't want to go that rabbit hole. So it's really important to be really really reliable on those tests. So let's jump into like Search Console. So if I don't have it open here, so I should go do it here. So in Search Console, like I mentioned, there is Crux report. So you have on the left, and maybe I should bump it again. You have like core web vitals, but I'm not sure if it's there for every website. And this is basically real user monitoring by Chrome. So we didn't have to do anything for it. And then I can like desktop or mobile, like mostly desktop will be always pretty good. Then you can open the report and then you can see like, okay, where are we doing a bad job? And we have some issues here, like LCP is longer than 4 seconds for our users. And then you can dive into which URLs. Okay, mostly just Showcase. And we know that Showcase is a bit heavy because it has so many images and so much data. And you also have to, like, we should fix this, but again, like, it's not our main point of entry. So most people go to like our homepage, like just make sure that this one is optimized, and like the overall view of it is pretty good. So you can go back to here, and then you can also like needs improvement. Okay, they are okay. We can do better there as well. We can again click on this one. We see way more URLs. Like again, starters comes up, Gatsby days comes up. Like, okay, not that many, so we're pretty good here. And then, but this is more core web vitals. And what I know is that this one page experience is technically what they'll use for search engine optimization or for your search ranking. And then it shows like we have 73.6% good URLs and 1.34 million impressions went to it. So it shows you like what are we doing okay job or not, and then we can dive into them again, and we see then like, okay, what should we focus on? But this Google Search Console is more for the SEO or the search engine part of things, but it's also helpful because you don't have to pay for real user monitoring. And then if we go to what's the other one that I mentioned, like Google Analytics is something we'll add, but then if you go into the lab,
Hey, Ward, before we get to that, we've got a question in the chat from John Hansen Artist, who says, I find that Gatsby does make it super easy to get high Lighthouse scores. Using Google Analytics and even worse, Facebook Pixel Tracker really drag things down. Is there a way to get these to work better within Gatsby? I do use plugins for this still.
Yeah, so at this moment, we need to add some extra changes to our Google Analytics and Google plugin, Google Tag Manager, and probably the Facebook Pixel and all of those. And we basically did it on our homepage. So we have been testing some things, and I don't know if I should change it to a dark color, maybe, or light.
Can you make the text, it's pretty small, so make it like a lot bigger. Great.
So what we've done for, in the meantime, but we want to, this is not the right file. We need to move it to the plugin itself. But for our homepage, we disabled Google Analytics and Google GTM, but we did our own, let me remove this. This is what I was going to show later, but I can already show it here. So basically what we've done here is we wait for on initial client render, and it's a hook into Gatsby browser, and we can look it up because this doesn't mean much for our viewers or Gatsby users. So if you go to our docs, like I just Googled and I picked the first result. And then if we go to the API itself, called when the initial but not subsequent render of Gatsby app is done on the client. So it basically means when React.hydrate is done, then we're going to then this lifecycle gets done, and then we fire away the pixel cannons. And why are we doing it? Because when we do it earlier, and that's basically what Google Tag Manager and Analytics is wired to do so, they will interfere with your network requests. It takes resources from your browser, and basically you want to focus on getting your content ready, and then trying to start measuring what your users are doing. And I know it's difficult to tell marketing, your marketing team that, because they do not understand that much, and mostly they say like, we need the data as fast as we can, but they also understand when it hurts performance and doesn't give you a satisfaction for your users, and then they're mostly okay with it. And there are things like A/B testing. You want to load it as fast as you can, but they have big consequences on your load time, which I can bring up like a web page test. And Webpagetest is another tool which I'll dive into as well. But what's really fun about it, so you have, if you do a run, you get like multiple ones. And if you go to like run, you do the first few, or like basically this is a median of all the runs and basically picks the one that comes closest to the median. So for us, it's run 6. And then you can basically look at, okay, what's happening here? And like Gatsby's loading, it takes about 1 second and 137 milliseconds to actually load the HTML fully. But we have postponed GTM. So what happened before was that this one was somewhere at the same level as all our JavaScript files. And that would also mean that all of these calls would be starting way sooner. And you can imagine if like you have to think about your network connection. Let's say you have 100 megabits connection. It doesn't really matter if you know what 100 megabits means, but it's more like you have only 100 rows, like or maybe on a highway you have 5 rows next to each other, like roads, and even if you have 100 cars and you just ram them through those 5 lanes, it wouldn't wouldn't get faster. And then like it's better to send like maybe 5 because they can just cruise through it, and then the next 5 and the next 5 and the next 5. And that's basically what you have to be mindful of as well. Like the browser does a pretty good job when it comes through like knowing which network request to prioritize and which not, because every type of request has a weight. Like for example, a JavaScript file on this one has a weight of 220, which is lower or higher than, for example, an SVG. So SVG has 147. So those are all the things that the browser and the server needs to know. And that's basically why because most of the tracking scripts are also JavaScript, they will compete with these Gatsby ones. So this might only take like 800 milliseconds, but the more you put through them, the longer they will get, because your bandwidth is only as big as you basically pay for. So you have to be mindful of your requests as well. Even if sometimes people say that you have HTTP2, like because like I think with HTTP1 you only could have like 6 connections per domain, and now with HTTP2 there's no limit anymore. There is a limit that the browser handles, but from the protocol point of view, there is no limit. So you can load as much assets you want parallelized or in parallel, but you also have to be mindful of the request you send. So that's why you should still make sure that your payloads are big enough. That's also the reason why we still bundle with tools like Webpack, for example, because if we wouldn't, why not just use JavaScript modules where you do dynamic imports everywhere and they just grab. But then you will have, if you have a large website with lots of node modules or just lots of components, you will maybe hit like 50 or 100 JavaScript files. It would just take too long to get them all through. So it's basically better to like do like 35 or 10 kilobytes chunks. I don't know if that answers the questions more or less. So yeah, so the answer of the question is postpone your pieces as long, because then you can see that we only have a small red area here, and those red areas are the long tasks that I talked about that basically measure TBT, because when we look at total blocking time here, we are not that great. I would even say that we're really bad. But I was going to show you why this was happening. So basically, when we go back to TBT, we saw that it measures all those red blocks here. And then if we go back to Webpagetest, we see the same red. Basically, red means that the CPU is under load, so their interactivities have to wait before they can handle. So let's say we are in this piece and you click on a button or like a link, your browser might freeze and might need to wait these 2 seconds. So it's really bad to have like a long blue line, or I think it's blue, like I'm colorblind, maybe it's pink. Like these lines should be really small, and basically everything that's long and red should be avoided. And I know from diving into the Gatsby code base that this is the React hydrate, and I'll show you like a few pieces like later on like how we can measure this and find the components that are slow. I guess I'll go back to my slides. So I explained Webpagetest, and what I like about Webpagetest, so let's say we go like run a test, and I'm not going to do it live, but I'm going to show you what you should be mindful of when you run one and why I like it so much. So you need your URL, and then you go to home. So basically this is your home page. You enter the URL you want to test. Then you choose the test location. So if you want to kind of mimic what Lighthouse does, you should use DevTools VA USA, and then you have the option to choose like a real device, the Moto G4. And this is actually a real Moto G4 that's sitting in a data warehouse somewhere, I guess, or maybe someone's basement. And then you go to advanced settings because you kind of want to set it up to like 6 or more, like 3 sometimes not enough. And then it depends on what you want to measure, but mostly first view is fine. Like repeat view only makes sense if you don't have your cache headers set up correctly. But if you use Gatsby Clouds with Gatsby hosting and then Gatsby plugin Gatsby Clouds, everything is set for you and you don't have to care about cache headers because we'll take care of everything. Then capture video is a fun one, and then because you can look at your traces, and then label, you can just name it whatever you want. Then advanced, mostly we skip it, but you could do some like disable JavaScript or other things. Chromium, it depends on how advanced you are yourself. Like sometimes capture V8 runtime calls make sense, and then it basically shows up where garbage collection is happening, like some internals, which you probably don't need, but sometimes it could be helpful. Capture network logs, so you can read them, read what's happening, like how do they look, like does your GET request, is it a post, all of those kind of things. But mostly the default settings are fine, and then you can capture Lighthouse report, and then you get also a Lighthouse run. And then you just hit start test and you wait. And now 18 pending tests are happening. So sometimes this is like 100 or 200, so it might take a while. And let's say you don't want to do this advanced testing. Like if you don't want to deal with Webpagetest, all those advanced settings, there's also simple testing, which basically tests on a real device like the Motorola Gen 4 with a fast 3G connection. You can even choose which connection, and it does a pretty good run for you, but it only does 3 runs and not 6, which like I like 6, mostly helps with getting good numbers. So if you go back, then you basically get the same summary, but the fun thing is, let's say we dive into run 6, the bottom here, we can see that like film strip view. I mostly put this on 0.1 second and then fully loaded. And you will see the same waterfall as we saw before, but it's pretty interactive. So this line I think it's red, maybe it's another color. But you can see like nothing is happening because this is the same line, a red line as here. So nothing is happening, and then from 1.7 seconds, oops, like now we're starting to show things, but why did it take so long? And from this point of view, you would guess like, oh, it should load from 1 second, like after 1 second when HTML is done, but the browser needs to do way more, like has to evaluate CSS, has to parse HTML. And if we go to our gatsbyjs.com website and we scroll down, like, it is a pretty large website, right? So if we look at like, there's a lot of like, okay, we have tabs here, we have testimonials, and let's say if we think I can click on it. So basically the file itself is like 70 kilobytes, which is not that large, but it's compressed. But then basically the browser has to uncompress it, and then you get like a 326 kilobyte file. So if I do a view source, and this is like not that big, but it's minified, or yeah, minified. So let's say if I use a format HTML tool, I hope it will work because it's a big file. Yes. And let's say if I copy to clipboard and then paste it in like here. And maybe I should do also wrap. So we're around 2000 lines, and then if you scroll, like we have SVGs, there's a lot of things that the browser needs to do to unpack. We also have a massive CSS, inline CSS file, or in CSS piece of it. So no wonder that our load happened so late. And I'll jump to DevTools as well to show you, like, to get a better understanding of like, where does this gap come from? Because now I'm just talking about it, but you cannot see it from this view. Like the waterfall is just for network. And you can see these browser main thread, what it's doing, and it's calculating layout and other things. But if you don't know, you don't get it from this view. And then you basically see like, okay, what's happening? And for us, it's pretty stable. There's nothing much jumping around. But what you could see is that you maybe see like it loads the top navbar first, and then maybe 300 milliseconds later, it shows a text, all of those kind of things. And that's where you maybe could see that there's a CSS file that needs to load, or like an image that needs to load, like all those things. And then it becomes super nice to just see like, what is it waiting for? Because let's say you have A/B testing and it's like a sync script. So you just do script source and then the URL. Then you will see that it has to wait for it to load, and then it can start executing. And you can also create a video, so you could compare multiple pages. Just give me 1 second, Megan, because I hear that you want to say something. So let's say you go to 30 seconds and you want to compare like an old one with like a new one. You can click on compare, and then you can also create a video, and then you get like a nice video next to each other to just and then you can see like which one is faster. Sometimes really nice to show as a demo, like, hey, we did some improvements and this is the outcome. So yeah, go ahead, Megan.
Okay, we've got another question in the chat from John Hansen Artist. How important is it to use the suggested browser caching using cache control headers setting in a self-hosted service in the context of Lighthouse and page speed test?
For your numbers in Lighthouse, it doesn't matter at all because they just do the first few. Like you get recommendations to fix, like if you don't use it at all, but it doesn't matter for how they measure, because they will also always do a clear cache before they measure. But for users, and for your basically for your costs, it would matter as well. Like let's say you pay for a CDN, like if it's self-hosted, you just have a VPS or like a shared web hosting, and you probably have enough bandwidth that you don't have to worry about. But let's say you pay per gigabyte or per terabyte. If it has the right cache control headers, it might never need to go to the network again, or maybe it only hits the network to check if it needs an update. And then instead of downloading a 30 kilobyte file, it might only get like 500 bytes because it just gets like a 301 back from the server, like, hey, nothing changed. And then, okay, cool. But if you do not have those, you might download those 30 kilobytes every time for every user. And like your bill might explode. So it is important, but not for your metrics. And then PageSpeed Insights and Lighthouse, those are much faster tests, or they run pretty fast. And like PageSpeed Insights, when you go to it, it technically runs Lighthouse under the hood. Like it's not 100% Lighthouse. It's like a little bit different, but you can basically say that it's the same. And then like what you would see, like it's way faster. Like I think they do a run in like 20 to 30 seconds. But what you need to know is that they do a simulated run. Like they run a super fast. So they basically run it on a desktop, and then they throttle, and then they basically do some math calculations. Like, okay, this network request was 200 milliseconds on a fast connection. On 4G, we multiply it by 4. And those are not the right metrics, but just to give you a clarification on like what does a simulated run means. So it's less correct than what Webpagetest does on a real device, but it comes very close. So if you just want to rapidly see something, you can just use this. And then you get, for us again, like we get this field data. This is basically from the Crux dashboard that I showed from here, like the Search Console. Maybe I should zoom in again. But it shows that like for 43%, we're doing pretty good. And only for 8% we're doing really bad, and bad means higher than 3 seconds. The downside is that we don't see which connection from here, but like our dashboards, like Crux dashboards can help you here as well. But that means like we're not doing that bad. Like our score might not be great, like 57, but the score is calculated on these things. And that brings me to my next point is like, how is this score being calculated? And what many people do not know is that like this sentence here, you can go to the docs where it tells you about like, okay, how are scores calculated and how do they fluctuate and all of this. It shows you like, okay, this is 50%, like first contentful paint, 50% of the score, speed index, 50% of the score, 15% of the score, LCP 25, and so on and so on. But the other fun one is the calculator one, where you can play, like where you can play with the metrics. So let's say, okay, first contentful paint, 85%. And it could be that I do another run that my score is higher. So that's why what I like to do is use Webpagetest for these tests. Webpagetest for these tests. It's a difficult, not the right Webpagetest one. So this one. Let's go back to this view. And what I like to do is, because this is a real device, I know that is going to be as real as it can be. And then I can basically copy first contentful paint 165, and I can copy it. I cannot copy it here, which I should talk to the team to make it like a editable field, but we can change it in here, like FCP, change it to 1657, or I can just move the needle roughly. But you see that the score changes on the right. And then you basically can see like, when do I get 100? Okay, when I'm roughly here, then you get 100, so 50 points on your calculator. You can also see like, okay, I would get like plus 19. Oh, it's FCP, so it's this one. And then you can do it with every metric. So what I like to do is just copy these numbers over there, and then you basically get like the real score. And then when we do it again, like when I did it for Webpagetest, and I think I have, do I have, no, didn't save. Yeah, I saved it on a different slide. So if I go to this URL, technically when I filled in everything from Webpagetest, I got a score of 64. And then again, like, we didn't get 100, but why? And then these two darn metrics, they pop up, like TTI and TBT. They're not used for search engine, but still, we want to give our users a great experience. And even if they do not see it, because this is again like a really old device and a slow connection, you have to be mindful of, like, this is like worst case. But when it's fast on a slow device, you know it's going to be blazing fast on a better device or a good device. Do I want to tell anything else? So the Crux report, which I talked about, is pretty neat too. So they have a blog post about it as well. Like if you just Google web.dev Crux, you'll see it. It basically explains you how do you get a nice dashboard like these, because the Search Console shows you a pretty good view of things, but they do not show you like which device, like which connection, which device, and I lost my tab. Which device, which connection, and it's like a more deep dive of like what's happening. So I think this one, so you can see like, okay, LCP, but you can dive into like desktop phone, which connections, and all of that. But I'll see that we are already really deep into time, or like very far, so I'm just going to skip a few things. Like I said, we were at for 53, and then by changing analytics tracking scripts to the end, like after Gatsby was done hydrating, or React was done hydrating, that helped to move our scores up because TTI dropped. And then improve SSR styling, what we've noticed, and that's something we really need to move back to the plugin, is when I should have it open somewhere to show. Is it this one? No. I think I did a test somewhere. If I go this one. Don't think it's this one. Nope. I think it's maybe it's this one. Nope. Because there was, I should have a. Let me see if I can find it, because it's really nice overview of like how bad CSS and JS can get when you do not optimize it correctly. Let me see if I have it on PageSpeed Insights. No. So basically what I was seeing, maybe I should just explain it then. I am curious. Yeah. So basically what Emotion was doing is around every component, before every component, you will see a style tag. And maybe Team UI has it too, because I don't think I can explain it very well if I don't have the, maybe I should just copy this. So basically what it was doing is, let's say I have this file, and then before every component I had like style, this, and then my CSS, and then for a div, and then here again, style. And it's not the fault of Emotion per se, because they don't know where to put those styles. Yeah, another class. But you had like style div, and so on and so on. And basically it made it super hard for the browser to calculate these things, because every time they hit a style tag, it has to reconfigure its CSS part of it. So if we go to our gatsbyjs.com website, gatsbyjs.com, and I do performance trace, so I do open DevTools, go to performance. You mostly want to do the same thing as like Lighthouse do, but because I don't want to measure network, I just slow down my CPU, and it's just to because I have a really powerful device, I kind of want to throttle it down as well, just to make sure that the traces are more viewable. But what we saw with Emotion, what was happening is that when we see the trace, and let's move this up. There I go. We had like a lot of recalc and layouts, like even more than we have now. So now we have parse HTML recalc, and it was happening like 100 times. So we had lots of spikes, and it was like just fighting with the browser basically. So what we've done in our own website, so if we go to Gatsby server, and this is again, we need to port this back. We added the cache provider from Emotion. So this is still Emotion 9 or 10. 11 is the newest one, I think. And we basically said cache provider, create cache, and then we wrapped everything, wrap root element, added this, and then inside Gatsby server or Gatsby SSR, we had to do the same. So we basically replace the renderer, we create a cache, we extract critical CSS, add a cache provider, and then we add the style tag with all these CSS. And then basically Emotion knows like, okay, SSR happened. I do not have to regenerate all the styling again, because now we have at the top, I know, we have like a style tag. This one that we generate at the top now, which has all the class or all the hashes of class names, and then all the inline CSS that's generated by Emotion. But now we do not have any style tags anymore during the DOM. It just helped the browser a lot. So total blocking time and time to interactive dropped like by a mile. We also
got another question in the chat. John Hansen, artist again. Great questions. There's a lot of trends today that are more about fancy animations and larger hero images and videos. What happens when the client wants proof of high scores, yet also wants the fancy JavaScript CSS animations and those larger images?
I I think you dropped your sound, so I
Ooh.
didn't hear the total, or maybe it was on my end. Could you repeat the
Can you
question again?
see it? Yeah. So basically, the question is about like how do you balance clients wanting high scores, but also wanting things like more fancy JavaScript, CSS animations, and like big hero images and videos?
You don't. The only thing you can do is like make sure that they load as fast as you can. Like hero images, you can pretty much fix by adding preloads. So basically, um, doing something like set head components. Like you should do it in like on render body. What you can do is like what we done. We done it somewhere. Maybe here. Basically adding like a link rel preload and then source the path to the asset. So let's say hero.jpg, and then you add like a type, which is don't know it by heart. Is it text CSS or style sheet? I think it's no, it's as, and then it's style sheet. And this helps the browser. So when the browser hits it, they know like, okay, I'll already start adding like downloading a hero image. And even better is to add it to your network requests. So let's say if I open gatsbyjs.com and I go into my network tab and then headers, what you can see is that we add a lot of link headers. So if you have your image here as well, it would just when the browser basically gets the request, it could already prioritize assets, which we'll see in the Webpagetest here, where basically if we didn't add preloads, this would only happen to start when the HTML is done, or roughly when it's done. But now, because it's part of the HTTP headers, they can start loading faster. So you basically should, excuse me, like add it to like images, videos, to your preloads. And that's the only thing you can do. Like animations, what might be useful is to not do them at the top, but maybe when they scroll, they start running, or maybe below the fold. And make sure to add like reduce motion APIs. So when maybe I'm not sure, but maybe like PageSpeed Insights runs it by default with reduce motion, so the animation doesn't start when it's enabled. But there's not much you can do, only by like making sure that they are compressed, have the right format, all of those kind of things. That's the only thing you can do. But you should also talk to your business people and designers like, hey, this will not be great for or performance or perceived performance, and yeah, just start a conversation. Because fonts is a big deal, because sometimes people load like 6 custom fonts, and you have to question yourself, like, wouldn't be one enough? So those are basically the things you have to be careful about. Then another thing we saw is that load only polyfills when necessary, and we've done this for a really long time. So in Gatsby browser, when you do on client entry, we basically had like if intersection observer is not defined, we do require intersection observer. The thing with when you use require is even if you have this if, it will be part of the JavaScript bundle. So we saw like our app bundle, because of all these polyfills, was added like 30-40 kilobytes for code that maybe that's only necessary for like Internet Explorer. Like for example, the object fit polyfill is only necessary there, and then is none only there, and most of our users, and you can use Google Analytics or whatever to measure it, is like most of our users are Chrome based or like evergreen, like Firefox, like the latest and greatest. And then why would someone on Chrome needs to load an extra 50 kilobytes for no real reason. So basically, if you create like an array like polyfills and then import section observer, they basically all become dynamic assets, so they get loaded when only they're necessary. And then because we use the on-client entry browser API or Gatsby browser hook, we still wait until they are loaded before we continue React. So you get like all the benefits you are like all the things you had before. Like if the browser needs a polyfill, we'll wait for it. If it doesn't, we just go super fast. And you save a lot of kilobytes, and basically it's done by dynamically imports. And then we gave them a name because then we have assets that basically say match all polyfill, and then it's just for debugging basically that it helps. Next thing, like improve font loading by using CSS classes. What we see a lot is that people use font display, the new hot CSS property. So it's auto block swap fallback optional, and basically tells the browser mostly we set it to swap because then we start with the fallback font, and then later on when the font is downloaded, we replace it, and then you get like a small jump. But sometimes the fallback font is not on the same level or like way different than the web font, like I mentioned. So this could become 4 lines instead of 5 lines, and you get like a jump. And with class names, which is like way more difficult to, like it's more work from a developer point of view, but you could like change the font, like maybe the default font is 4 lines, but you kind of want to have it 5 lines. So maybe you should boost up the font size when it's a fallback font, and when it's not. When the web font gets loaded, you add the class and then you change basically the text. And a good Gatsby plugin for it is Gatsby plugin Omni Font Loader. This basically takes care of almost everything with the class names. So it adds like pre-connects and everything. But the cool thing about this is that you reduce your largest console paint because there will be no text shift basically when it happens. So you just get like, it will stay 5 lines. You might get like a little bit bolder font or something, but at least it doesn't messes up with your scores. And there's also another problem with web fonts loading. Every time a web font gets loaded, you get a layout change. So basically when we go back to this one, every time fonts load, like layout needs to be recalculated, and styles as well. So let's say you have 8 web fonts. Every time it loads, you basically have to do a layout. And on a large page like this one, it can get expensive because it's might get like 300 milliseconds. Now they're pretty fast. But you get it 6 times, and maybe you want to bundle it together. So with class names like fonts loaded class name, you can all bundle those changes together so you get only one layout. But you have to like make the decision yourself. Is it worth the dev work or not? Because most of the time fonts display swap works. And then other things we've seen is like, because I think I have to wrap up, is like Gatsby Cloud hosting, enable it, or go to gatsbycloud.com and then just sign up for hosting, because we use Fastly under the hood, one of the best CDNs available, and then we optimize all the network requests for you. Like we add the headers, we make sure that it's super fast, and we've seen that even from other known CDNs or hosting providers, you just get free Lighthouse performance scores. And then upgrade to Gatsby v3, because in Webpack v2 we could only do app level tree shaking. So what that means is basically if you used, let's say, React icon somewhere, we could, if you used it on 10 pages, like one icon on page 1 and another icon on page 2 and so on, we would bundle those 10 icons on every page, which with like a which could become really big, really fast. And with V3, we can do it on a page level. So if you use one icon on page 1, only the icon will be added to the page and not the whole library or like all the other 9 icons. So that's a big win. We also tried content visibility CSS property, which is a new one, but we didn't see much improvements on the rendering piece of it. We didn't have too much images, like it was not that, but it could be for you. Basically, it's lazy renders pieces of your browser, of the browser, and you don't have to do anything for it, like search still works and all of this. Like there is some accessibility issues with it that I don't remember. So you also have to be careful that it does what you want it to do. So again, like the Lighthouse score 64, like what's holding us back? Mostly it's technical depth and complex components. And I just want to show one little thing on like my local host, and then I think we can wrap up afterwards. If it wants to run, maybe the process crashed. I hope not. Okay, yes, no, that's fine. So when you so a great tool to install is React DevTools. If you haven't yet, you should, because you can, like in Dev, you can see like which components am I rendering. But the cool thing that I can show now is if you open the profiler, you can basically profile your React type or your React hydration and everything. So like I mentioned here, we have this really big blue line, and it comes from app.js, which like I know it's the React hydrate piece of it. And it basically takes most of the time spent for total blocking time calculations. So if I go here and then the profiler and I click on this one, reload and start profiling, what I should do as well is put throttling again on 4 times, because then it blows up the traces, so it's easier to find bad components. So if I profile, the page should reload. And again, this is like dev mode. Oh, great. Get this one. So it's dev mode, so it doesn't show. Oh, no, wait a sec. So it doesn't. What did I say? So it's not the production React. So it's slower than if it's runs on production. So these scores are a little bit skewed, but they should show you enough to basically see what's going on. And I don't know, because I get this unhandled runtime error, I might not see everything. But you can see that the page header, for example, takes 100 milliseconds to render, and then this one 114, which is quite a lot. Like normally they should be like 5 milliseconds or something. So if you go to those smaller ones, they're like 6. And they just show you like, okay, this component is pretty expensive, or like the header navigation takes 87 milliseconds. Okay, I'll go down, like even more down the road. Okay, header nav mobile, 15 milliseconds, and so on and so on. And this is how you can figure out which are expensive components. So these header nav sections are pretty expensive, and I can scroll down, so I see all of those, and they just add up. So I could look at our code for header nav section, and then see like, okay, what is it doing? Go inside, and then like it's different for everyone because it's your own code. And then you could start maybe I remove this, and then if I put it back, and I can do another trace because I'm in DevTools, like I'm in development mode, and then I can do another trace. And basically, if now I've added it, and then when it's done, do another trace, and then like my render time will blow up like to like 150 milliseconds or even more. And that's how you can like figure out which are bad components, which are, and how do I optimize them. So see, like header nav is now 500 milliseconds, which is like, when we look at like this rate again, like I think this one's around 1 second or something. Half of it is, or 1.5 seconds is like half a second is wasted on the navigation. That should like, okay, maybe we should refactor this and make it faster. Like, why is it so expensive and all of those things? But it gives you a lot of extra work or extra information on like, okay, TBT is slow, which mostly for Gatsby site is where React spends its time, and it's not that React is slow per se, like probably both a little bit, but it's also like, okay, we have a really expensive component here. It does a lot of things. Do we want to do those things? Maybe can we postpone them, or can we maybe change the design a little bit to make it work? So let's say for us, it's like on hover effects. Why would I want to load this one at page load? Like, why don't I wait maybe for someone hovers over it, and then I basically load the content of this one and show it? Like, all those kind of things are possible. But again, you need to be mindful of like, what are you trying to fix here? Like, what are those things? And I think I'm gonna, like, I would love to spend more time into like these I would call it nerdy pieces of performance. Like, okay, this is slow. Why is it slow? Maybe that's for another stream. But um, we, like, all those things are pretty hard to figure out. But Gatsby does a lot of things for you, but these things sadly we cannot do. But we have a concierge service. I have not said it correctly, concierge service, where we help our customers like get the best Lighthouse scores they want, and basically improve the whole website experience. Like, we do a lot of pieces, like we do performance, we do also build performance audits. We help you onboard on Gatsby Cloud and all of it. So if you find this all interesting, but it's like maybe top of your head or something, or you just like, don't want to deal with this, let the Gatsby experts deal with it instead, you can always reach us out. And the URL is gatsbyjust.com/concierge. And also make sure to check out Gatsby Cloud to look at our build pipeline, and also more important, our hosting provider like Fastly CDN is we're using under the hood to make sure that your CDN is configured the best as we can. And that's basically it. I hope you enjoyed it. If there are any questions, we might be able to take some more.
Yeah, this was great. I learned a lot of things, and now I have like a long list of tools that I want to go and run on my own website. So thank you so much for coming on and sharing. And we would love to have you on a future stream to come and nerd out about other performance things.
Yeah, time flies when
I guess.
you...
Yeah. If nobody has any questions, I guess if you were going to try and summarize like your number one thing that you want people to take away from this, what would that be?
I would say measure your website, like do it on every change you make, like set some kind of performance budgets, or like make sure that you don't digress. But the most important thing I want to say is like, do not focus too much on the Lighthouse scores itself, more on the user experience. Like, if it feels fast, if it's like, if you're using it yourself on your phone and everything, and it just feels fast and right, that's the experience you want to create. And getting 100 is fun to show off, but it's not necessary. Like I said, total blocking time is measured on Lighthouse or PageSpeed Insights, but it's not measured by SEO tools. So that's just something to be mindful of. Like, our website TBT was off the roof, but our SEO is not tackled by it, because like it's not measured there. Like, fit was like super good for us. Like, first input delay is about 100 milliseconds or 50 milliseconds. So I should just be mindful of it. And if you use our website, I don't think anyone would say that it feels slow.
And if it does, let us know.
Yeah, yes.
Well, thanks again, Ward. Just to tease for folks, next week we're going to be talking some fun stuff about e-commerce and how to use a new cool e-commerce tool. More about that next time. So we will chat with you next week. Thanks, Ward.
Yeah, thank you. Bye-bye.
Bye, everybody.